Hello everyone, this is Dr. Ian. For today, we're going to be talking about triangles, how to construct them, and how to measure some angles using its properties. Language is important in mathematics, and we're going to add more terms and vocabulary that we need to know to be able to answer more problems in geometry. And we're going to start with the types of angles that we have when we see triangles. So we are just going to be focusing on this special type of polygon or a three-sided polygon in our lesson for today. So first is interior angles. And you will notice that in our triangle, our lines are extended and you are seeing angles A, B, and C, which is outside our triangle, and angle 1, 2, and 3, which are inside our triangle. So these angles, angle 1, 2, and 3 is what we call as the interior angles. And in these angles, it's important because we'll be able to learn some of the properties and theorems associated with our interior angles and also our exterior angles. So identifying interior angles is quite easy because all you need to do is to just look at the angles formed inside our triangle. And in the exterior angles, let's see how many exterior angles you can count using this diagram. And from here, angle 1, 2, and 3 are all inside or interior angles. And if we have exterior angles, which is defined as the angles that are adjacent to the interior angles, we'll be able to produce 1, 2, 3, 4, 5, and 6 exterior angles from the extended lines that we are seeing in our triangle. And notice that we have triangle A, B, and C that is vertical to 1, 2, and 3. And that means those angles are congruent. And speaking of vertical angles, you will also notice that 4 and 5, 9 and 8, and 6 and 7 are all vertical angles, which means those pairs of angles are congruent. And when that happens, especially in mathematics, we always want to simplify things. So instead of just naming 4, 5, 9, 8, and 6, 7, we can simplify it by just focusing on 4, 6, and 8. And why can we do that? It's because its opposite angles are just congruent for those angles, so we can define those as exterior angles as shown in this diagram. So there are two exterior angles associated with each interior angles in a triangle, which is 4, 5, and 6. 4, 6, and 8 from our original diagram. But since these two exterior angles are congruent, or vertical angles, we usually show only one exterior angle with each interior angle. So these are the relationship that we usually use when we are working with triangles. And speaking of triangles, let's start working with some of the theorems associated with the interior angle of a triangle, similar to what we are seeing in our diagram right here. So we are seeing three angles because we are using a triangle, and we know that the sum of the measure of the interior angles of this triangle is always going to equal to 180 degrees. And with that in mind, we're able to produce the triangle angle sum theorem, which is one of the most popular theorem that we use in geometry, and it's also helpful in measuring angles not just in triangle, but in any other type of figures involving sides and angles like so. So how are we going to use this theorem in finding the values of the angles of this triangle, knowing that the first corner is 5x, the other one is 6x, and the other one is 15x plus 24. There's no specific angle measurement in this diagram, but we know that we'll be able to compute and calculate that using algebra and geometry. So let's start with using algebra to find the value of x. So we have this triangle. Let's say this is angle 1, 2, and 3 as reference, and we know that angle 1 is 5x, 6x, and 15x plus 24. What we know about the sum of the interior angle of a triangle, so if we add angle 1, angle 2, and angle 3, it will equal to 180 degrees because of the interior angle sum theorem. And knowing that angle 1 is 5x, and angle 2 is 6x, and angle 3 is 15x plus 24, we now have an algebraic equation that will help us in solving our value of x. And to do that, we're combining like terms, and all of these three is equal to 26x plus 24 equals 180 degrees. Subtracting both sides by 24, we'll have 26x is equal to 180 minus 24, which is equal to 156. And by dividing both sides by 26, x is now equal to 6. And now we're able to use algebra to find the values of angle 1, 2, and 3. And to be able to do that, all you have to do is replace x by 6, 6, and 6. And using algebra, we know that we'll be able to complete our angles because by formulating the equation that we have using our theorem, we're now able to produce the value of x, which help us to find the value of 5x, which is 30 degrees, 6x, which is 36 degrees, and 15x plus 24, which is 114 degrees. And we know that we did it correctly, or we calculated the angles correctly, because if we add them up, it will equal to 180 degrees. And that is how we use and combine our skill in algebra and geometry to solve problems similar to what we've just completed in this slide. And now, let's review on the types of triangles that we have in geometry according to its sides. We have scalene, isosceles, and equilateral, and we're going to be producing these types of triangle without using the scale of a ruler, but just our compass and our paper. So let's start clearing our workstation right here and use these tools to produce these types of triangle. And we're going to start with equilateral triangle, which is really easy if you have a compass, because all you need to do is to produce a straight line and a circle. So the first step is to create a straight line, and from this straight line, let's assign a center or a point in between these two ends right here. So let's say this point is what we're going to start with, and this is our radius. Radius because with the use of the compass, you can adjust your compass if you want a bigger circle or a smaller circle. It doesn't matter as long as it's a circle. And by producing a circle using a compass, we're going to point our needle to the center. Now we'll be able to draw a perfect circle using our compass. And without changing our compass width, so this is important, you'll be able to produce an equilateral triangle by pointing your needle to the point right here, which is one of the radii of our circle, and create a curve like so. You don't need to complete another circle, you just need a curve, because you'll notice, and you know that you did it right, because the radius is intersecting your curve from this circle. And this is important because now we're able to produce point A and B. Let's say this is point A and B. And if we are going to connect A, B, and this point right here, which we're going to call C, we'll be able to produce a triangle that is equilateral and also equiangular, which means they have the same angle measurement. And we're able to produce that using our compass and straight edge. So we know that this is an equilateral triangle, and we know that it's true because if we use this ruler, So this is the measurement of this side, this is the measurement of this side, and this is the measurement of this side, and all of them are congruent. So now we're able to produce an equilateral triangle, and their angles are also congruent. So this type of triangle, we have congruent sides and congruent angles. And in geometry, we call them equilateral and equiangular. And if you have if I can spell it right, equiangular, I save it. This is equiangular triangle. So that means this is also a special type of polygon called regular polygon. So if your polygons are both equiangular and equilateral, they can be called as regular polygon. And now that we're able to produce our equilateral and also equiangular triangle, now let's produce isosceles triangle. And this is actually easier because all you need to do is to draw a straight line. And from this straight line, just pick random points on your line. So let's have A here and let's have B here. And all you need to do is to make sure that when you are using your compass is either shorter or longer than point A and point B. I'll make it shorter. So I'm going to adjust my compass like so. And now that I have a shorter width in my compass from A and B, by pointing B here or pointing the needle to B, and without changing my compass, I'll point my compass needle to A, and I'll be able to produce a point of intersection, and I'll call this point C. And if I connect BC and CA, now I'm able to produce an isosceles triangle, which means these two sides are congruent, and AB is, of course, we know, is not the same as AC and BC. So this is how we use our compass and straight edge to produce isosceles. And the last type of triangle, so let's not waste our paper and let's just draw a line right here. So this line, random line, let's pick a point. This is point A, and this is point B. And all you need to do is to use your compass. So this compass, it's shorter than AB. So let's use this measurement and draw a curve using the compass by pointing our needle to point B and drawing a curve like so. And then for point A, you need to now adjust your compass and make sure that the compass is not the same as AB. I'll make it a little wider like this, so I know it's wider. And I'll place my needle to A and draw a curve that will intersect my first curve. And now I'm able to produce point C right here. And if I connect B and C and C and A, now I'm able to produce a scalene triangle wherein all of the sides here have different measurements. So among the three triangles that we're able to produce, equilateral, isosceles, and scalene, only this holds a special property, which is a regular polygon, because they're both equilateral and equiangular. And that's how we construct and create our triangles using our compass and our straight edge. So our number bender challenge for the day, I'm not going to ask you to do or compose or use a compass to produce a triangle, but to find the value of angle C using the strategy or technique that we have learned in our lesson for today. So comment it down below and let's see if you'll be able to use your algebra and geometry skill to find the value of angle C. And this is our lesson for today. So remember that there are interior and exterior angles in a triangle, and you can also produce or construct any types of triangles using a compass if we only have a straight edge and the knowledge on how to produce those angles that will produce the specific triangles that we need in geometry. This is Dr. E, and see you again